कुछ नहीं. Hello, good evening, bachon. Very good evening. So today we will have an extra classes because we missed earlier. So I want to cope up those classes today. I hope everyone is fine with that. Um, okay. So I think it will be not a long lecture. We want to talk about today the premises, the where your plant gonna be, what other quality assurance technique has to be taken care there. How should be the premises look like according to the good manufacturing practices, all the sanitization, all the hygiene, all the fire extinguishers, all the gas lines, all the pipelines, how the all system need to be taken care while you're making the premises of your any industry or any things that you wanna start with, yeah, especially in the pharmaceutical industry. So that will be the focus of today's lecture. I think we can start now. Think this will be visible for all of you. So in this part, basically we will discuss many things. Basically, initially from starting, if we start the principal facilities, ancillary area, storage area, weighing area, production area, quality control area, various services, design, aseptic processing, lighting, plumbing, product disposal, sanitation, maintenance, and then preferences. So it's not when we see one industry or one setup is going to be started, it's not just gonna start in a day. So there's a lot of things has to be taken care before building that building. Many people will be coming up to join that part. So that is a whole bunch of work out there. So premises that you want to look for, it should be located, designed, constructed, adapted, and maintained for the operations, and it should have minimum risk of errors and contaminations, cross contamination. So, like if you're building a industry for ketchup, for sake, for tomato ketchup, now Kisan tomato ketchup. And in nearby you have one industry who's producing yeast. Yeah, a lot of yeast is being produced for cheese production. So it will be not nice to produce, to have your industry nearby that thing, so there will be cross contamination in your industry then because of their production. So better, when all the pharmaceutical companies, they are building their companies, so better that one product that is being produced in one industry, it should not be cross contaminated to the near industries. So be careful with that. Permit effective cleaning. Cleaning has to be clean, has to be taken care very well. All the hygiene purpose. Effective maintenance. Minimize the dirt and dust area, so it should not be like on the road where all the trains or all the cars and buses are moving around. So that will be also not nice. It should be away from the public places. It should be in the somewhere in the hilly areas, where there's less pollution and free out of all dirt and dust. Any adverse effects on the quality, there should be no adverse effect that should be coming on your quality of a product. So that's why these industries, they are always away from the city, away from the main big cities, and being built in the in the small areas. So premises must be localized, located, minimize the risk of cross contamination. For example, there is a malting factory with high bond level of yeast. Yeah, there's a nearby, as we have discussed. Let's say this is in, I think, in Melbourne, this industry. Just a second. Just a second, student. So sorry, my dog needs to get out of the room. So, as we discussed, there should be no cross contamination should be available to your malting factory, so that the high bond area of yeast should not come into your industry. So, it will be not good for producing your malt, I think. So, a map, from the architecture, just create a very nice map where should be what, how things will be coming up, how things will be going out, so that the food material, people, working place, yeah, everything needs to be in a nice way. So here we can see that there's incoming goods coming up in this green area. Yeah, raw materials and packaging storage are is there. Then weighing is done. Then the processing is done. Washing, machine shop, filling is done. Then the packaging is done there. Then the finished product storage. So utilities and services, waste treatment at the end here. So everything is being planned very nicely. There's corridors is being there. There's office on the corner. Quality control office is there. Material flow is going on. There's a small canteen also. Gowning is done in here with the all clothes, and then shipping in that corner. So that's basically a premises, a basic pattern of an industry looks like. So initially you have arrival of goods, visit entrance from here, workers entrance from here, and shipment of goods from here. Yeah. So raw material come from here, and the final products are going from there. So that's how the basic things are working out with them. So what are the basic facilities that are required in that industry? So basically, in the facilities, the first is adequate space. Yeah, you need proper space in there. They should be like. Is it okay if I also speak Hindi, students? I didn't ask you here. I think I asked you on the first day. If I speak Hindi also in between, is it fine or is it only English? Are there anyone who can't understand Hindi here? Don't be ashamed of that. It's totally fine. Um, I wasn't. I had my whole schooling in Delhi, but when I go to Punjab, everyone was laughing at me because I was not aware of Punjabi at that time. So they were saying that you are a born Punjabi, you can't speak Punjabi because I never learned that. So it's totally fine. We have never learned Hindi. It's okay to admit. If there's anyone there, अगर मैं हिंदी में अगर चाहूँ हिंदी में कर सकता हूँ. Otherwise, I continue in English. I have also no problem. It's just it's better to take you more deeper in Hindi language. हम ज़्यादा थोड़ा डीप जा सकते हैं चीज़ों के लिए rather than हम जब इंग्लिश में करते हैं. इंग्लिश में भी जा सकते हैं. Of course, we are going. There is no lack in that. I just want to confirm that everything is fine if I go both for English and Hindi. Is it fine with everyone? ठीक है, ठीक है. Another students, I needs everyone comment on it. बिकॉज एक मेरी रेगुलेटरी क्लासेस चल रही हैं, रेगुलेटरी ड्रग रेगुलेटरी अफेयर्स, उसमें हम हिंदी और इंग्लिश दोनों करते हैं. तो मैं पहली बार कर रहा हूँ. अभी तक मेरी जितनी भी क्लासेस थी वो सब मेरी इंग्लिश में ही होती थी, बट बच्चों ने कहा उसमें कि सर हमें हिंदी में भी चाहिए. तो मेरी पहली बार मैं एक बारी मेरा एक्सपेरिमेंट ही है एक्चुअली, बट ठीक चल रहा है अभी तक. तो अगर ठीक है तो हम हिंदी में भी करेंगे. अगर किसी को भी हिंदी में थोड़ी सी प्रॉब्लम आ रही है तो मुझे बता सकता है, तो मैं इंग्लिश में ही रखूँगा. क्योंकि ये जो हिंदी और इंग्लिश का जो है, या ओके फाइन. बिकॉज मैं जब जर्मनी में था, व्हेन आई वाज इन जर्मनी, वी यूज्ड टू हैव अ मीटिंग ऑफ 50 पीपल in our class or in outside. So I was the only one who was not good in German. So whole teachers, professor, they used to speak just for me in English only, so that the communication I could understand. Since that day, I have decided that if anyone is not, uh, what you say, comfortable in that language, if we should not do it. We should do that language in which all the communication of the lecture could be done and procured by the other participants also. So we keep it in English in that sense, so no worries. So zoning laws to allow anticipated developments, restricted undesirable development in the vicinity. So there should be some, there's some zone laws are there that you cannot process some water there. You cannot process sewage water. You cannot use that land for agriculture purposes. You cannot use that land for pharmaceutical industry. There's always some lands that are meant for something by the government that you cannot produce that industry. So there are zoning laws. So that has to be taken care. Availability of water, how much quality and quantity is it, power, fuel, sewage, and waste removal. So it's very important also the how you're gonna remove your waste and sewage there, because most of the industry in India especially, they don't have a good effective way for removing the waste, because there's a lot of money is required for that. And that's why Sweden is the #1 country at the moment who is known for from the industrial perspective for reusing the sewage and the waste material. So it's the most pure industry, that they are most green environment they are producing there. So you have to learn a lot from Sweden also. They have a lot of actual research being happening at the moment on the sewage and waste removal. Yeah. Accessibility of employees, materials, and visitors. All them employees that are coming up, all the materials and the visitors who want to check our material, they should all be accessible to each one of us, to each other. It should not be any hindrance to that. Some environmental issues about the land from the history perspective, soil, water, and air quality, how is it? So undesirable activity, if we do, that will lead to the pollution then. Availability of suitable labor force, people, skill, wage expectations, access to further education sources. Because if we are creating one industry away from the city, away in some hilly areas where there is no development there are no schools, no hospitals, no religious places, no sports facilities. Yeah, it's out away from everything. So slowly, when people start to work there, they need all these basic requirements. So it started to build the industry and education, schools, everything will be start to develop with the time, and it's become a small city also within itself if you make that place available. Security arrangement has to be there. It should not be like some people are coming looting your industry in the night, taking all away the products, and you can't do anything. So security arrangement has to be taken care very advocaatly in that manner also. And beyond that, political situations such as government stability, trade policies, taxations, financial incentives, all has to be maintained during the work. Site development plan will include so compliance with appropriate laws and regulations, any additional company standards. So site resources and infrastructures, site security and assesses, fences and cameras, building, sitting, layout, usage, functions, interrelationship for efficiency, possible expansion for service finishes, utilities like design, layout, backup, all things has to be taken care. So all these things are basic things, yeah, to establish your building. All the cameras, fences, layout, no, architectural work, how the design it should be, how you're gonna take care of electricity or some chemical operations you wanna take care, the equipments that you're gonna use, designs, layouts, spares, and capacity. Yeah, the traffic flow, that how pedestrians and vehicular work, these machines within the industry taking heavy loads from one place to another, how it will deal with the people who are walking within that industry on their walk. In that sense, actually, in the traffic flow, Amazon has played a big role here. So Amazon has around 80%, I don't know, 70% displaced by the robot itself. So all the work of moving your things that being coming up there, it has all been taken by the machine robots there. So when I was in Germany, I was asked to work there for some time when I was a student, and I saw the premises. There was a very less workload for the human beings. So all the things were done by the robots itself. The small robots on the floor, moving from one place to another. So they were taking things on their own. So we just have to make sure that things are going fine and just make a quality control over that. So this has been maintained very well so far at the moment. So they are also saying that in upcoming time they're going to replace human beings with most of the industry, and most of the human beings actually. Many industries are already there, and there's no man is required while doing so. Even the bus running, your train running, your IT software. We already have artificial intelligence now, machine learning. Alexa is being played role as a friend at the moment in many's life. So everything a robotic machine, cyber world is coming up. So everything will be automatically done. Safety is coming up for personal equipment, contaminants for hazardous materials and emergencies, and ease of maintenance. Like if there's any, the janitor has to be there. If there's anything that goes wrong, it should not take some ages. Like here we have to call if our meter is gone wrong or gas electricity is wrong in our houses or industry. So that the government people, they take ages to come and then start to repair, and they make bill. Oh, this happened, it's take like 1 week or so, and by that time there will be a lot of loss from the production side. Yeah, it could be loss for millions if the electricity gone or some fault is there from the water incoming or anything, raw material or your transportation, anything there's any trouble. So there should be ease of maintenance also in that sense. Okay, then comes your ancillary areas, which includes your refreshment and restroom, that should be separated from your manufacturing and control areas. So this has to be maintained also in our industry. In nowadays, it's not being in India, not given so much importance. But I was also working in the farmlands, in the agriculture areas. So we tend to have a very small room in which we used to be given one fridge, one kitchen, one clean water, and free available of all the refreshments like juices, cold drink, uh, you know distilled water, everything was free for us, and that was given by the company itself. It was a private company, it was not a government. So it's all about ethics, how you keep your ethics for your employees. If you want to keep your employees happy, and they will work for you in return hard. If you don't want to keep your employee happy, if you can't help, like make them happy, they will be always be complaining about this is not good, this that is not good. So if you want to work in scorching heat, cutting the grass roots, or making out the weeds out from the field by your own hand, manual hand, so it's a lot of work in the scorching sun, working like that. So we need to maintain uh, our things also then. So facilities for changing and storing clothes for washing and toilet purposes should be easily accessible, appropriate for the number of uses. Toilet should not be communicated directly with production or storage areas. Yeah, this hygienic part, these for the employees, they are coming up, they're changing their clothes. There should be separate room for that, for washing themselves, cleaning themselves, hygienic part. So everything has to be maintained properly. So all the big MNCs, Johnson and Johnson, GlaxoSmithKline, if you got a chance to work there after your studies are over, you will see a difference from one private companies and these big ventures, MNCs, multinational companies. You will see a difference. Maintenance workshop should be, if possible, separated from production areas also. So if some tools that are required in your industry, if they get wrong, so they should come bring up there and should be repaired by themselves. And if you're working in R&D field, working with guinea pigs, mouse, sheeps, they should be also be separated from the other area, and air handling facilities has to be there. Now the clean air is coming up inside that room, and the bad air is going outside from that. So the animals are not get infected by any chance from any disease from the outside. So these are big things, I know, but we need to maintain them. So and it is being maintained also, like in thermoscientific, all the big companies, they really do care when they are working in part of the pharmaceutical work or R&D work or biocon, so they are making sense in that, making lots of changes in that. So you can see here's a canteen is made with the washroom, and the sink is there, and people come eat and do something, and then there is a changing room here made, right? And all these things are airlocked. They are not being, air is coming in here and there. And there's a toilet there with the washroom and sinks and toilets, everything. And then there's a factory outside. Yeah? So these sanitary rooms, your washrooms should be clean as it looks like here. These are very small things, we never have even acknowledged them whenever we join some place. Just like, okay, it's being just made just for the human beings, but they are some of the key things which needs to be taken care, need to be planned beforehand before making things up. So we are talking very very small things which will be actually helpful in making things useful from the large perspective. Okay, then comes your storage areas. So storage areas should be sufficient capacity to allow orderly storage of the various categories of materials and products with proper separation and segregation. So yeah, because once your product is produced, you have to pack them in their baggage as per requirement. Is it plastic bags or thermocol bags, whichever the packaging is required. So they have to be packed evenly, like there should be not uneven products that are being produced. There's a famous this meme is coming up nowadays with the Twix chocolate. There's a famous guy from Ghana, I guess, I don't know, from Africa somewhere, who create very famous things. There was a model who was eating one chocolate from the production area, and when he was start to open his chocolate, he found only one chocolate out of it, and he said the one chocolate might be eaten by that lady. So this things has to be maintained. Sometimes in our food products, uh, like biscuits or any Maggie, we can see some defaults in them also, because we never know, out of 1,000 one product could be mishandled. So this has to be taken care. And storage area should be designed or adapted to ensure good storage condition has to be there. In particular, they should be clean, dry, sufficiently lit, maintained within acceptable temperature limits, with provided control monitored and recorded where appropriate. All the cameras, all the security guards clean, no mouse or any rodents should be there killing your things. Yeah. And receiving and dispatch batches should be separated, protect materials from the weather. So yeah, weather is also a problem. There should be not lot of humidity for your products or less humidity for your product. Lot of heat is also not good. So this might also destroy your products then. So some segregation if should be provided for storage of rejected, recalled, returned products, highly active or radioactive materials or narcotics or other dangerous drugs, which could catch fire, explosion, should be secure safely and secure areas. So make sure that things are being taken care. Printing of your packaging material labels has to be taken care, requires safe and secure storage. And there should be normally be separate sampling area for starting materials. If sampling is performed in storage area, it should be conducted in such a way it prevents contaminations or cross contamination. So the weighing of starting material and the estimation of yielding by weighing should be carried out in separate weighing areas designed for that use. So such areas may be part of either storage or production area. So whatever the product is being produced that you are maintaining in your packaging, it should be weighed in separate room in somewhere. All the products that are being produced, they are in the right order, in the right amount of weight. It should not be less or it should not be more. So that's what the quality assurance is playing role, that the premises that you're working on. So that's what we are discussing since the start of the lecture, that all these sections, all these things, storage section, production section, packaging section, the weighing section, your changing room sections, your canteen, your hygiene section, entrance section, going out section, and our shipping section, input section. So like we have discussed today in the first lecture today in these images. The premises, so they need to be separated nicely with the closed rooms. Air should not be come from one place to another, and maintained in a nice way. Yeah, so all these things play a big role there at the end of the day. Then comes your production area. So that's the main part. So we have discussed the raw material where is coming up, your packaging we have discussed, maintenance we have discussed, the weighing is we have discussed. Now comes the main part in between that is happening, the production area. Where is the maximum, your most of the things that's gonna play around, and it has to be maintained very well. So I don't know if you have anyone attended my MBBT class. I can show you one video where they are producing some enzymes, some proteins at a large scale. Yeah, they're producing yeast also in that scales. So we can understand that how people are there wearing their dress codes, and all the machines, all the things has to be very carefully taken care. There should be not a single 0.001% error should be there from the human beings. If there's one error by one human being, believe me, the next day that person is not going to work there. So if you do anything wrong, if you have done anything that is not up to the mark, I'm saying it from the international market, now from the international pharmaceutical companies. I have seen that by myself. If we are not up to the mark of their standards, believe me, next day they will say, okay, tata, bye bye. Like this Rahul Gandhi meme is there saying. I'm watching a lot of memes nowadays. So, just kidding. In order to minimize the risk of serious medical hazard due to cross contaminations. Dedicated and self contained facilities must be available for the production of particular pharmaceutical products, such as highly sensitive materials, for example, penicillin or live microorganisms, right? And production of certain other highly active products, such as antibiotics, hormones, cytotoxic substances, or non pharmaceutical products, should be contained not conducted in the same facilities. That you're producing your hormones and you're producing some antibiotics or some non-pharmaceutical products in the same industry, because you want to produce, because you have less space, you just started to work in the same field, in the same place. That will be a big disaster, believe me. Yeah, it's like we have one room and we give that room to six different people of different profession. One is musician, one is poetry writer, one is let's say athlete, third is something else. Everyone has their own profession different, and we told them you have to stay in this room only and you can do your hobbies within this room, and this will be a catastrophe. No six people will adjust with each other and work together, believe me. No one, no one. So they could be, if they have no option, you have to adjust sometimes, of course. But that's the way. If you make three or four industries, like different products, and you make in one room, it will be a very, very bad thing to do so. And manufacture of technical poisons, such as pesticides, herbicides, should not be allowed in premises used for the manufacture of pharmaceutical products. So, if you're producing poisons or some herbicides, pesticides, and you're also producing pharmaceutical products in the same industry, that will be a catastrophe. There, if even though you say that things are being separated, no one is coming from one place to another place, but believe me, there will be contamination one or another day. So these are very small things to discuss. We never know that what might happen if somebody deliberately wanted to do so. That there are people also within the industry, they do even these bad things. So, but to overcome that, we have cameras, security things, everything is there. So this has to be also maintained. And your premises should preferably be laid out in such a way that allow production to take place in areas connected in logical order, corresponding to the sequence of operations to the recognized cleanliness level. So, I mean, if I want to show you one video actually, students, because that will make sense that what we are talking at the moment, that how production is playing role here, because that will make a lot of sense if I play that video and then we continue with the things. Yeah, the purification. I want to talk about purification bioprocessing. It's a 19-minute video. Maybe I play that video only. We continue again tomorrow. Tomorrow we will also again class. It's no worries, we will take our time. But I wanted things to be covered in a nice way so that you are able to. So I will start the video.
Today, we rely heavily on biotechnology for many of the necessities of life. For the food we eat, the clothes we wear, fuels for transportation, earth-friendly plastics, pharmaceuticals to treat our illnesses, and dietary supplements to help us stay healthy. Many of these products are produced using three core biotechnology processes: fermentation, recovery, and purification. Fermentation is basically cell farming. We program cells to produce a product. We nurture them as they grow and reproduce, and then we harvest them. In recovery, we separate our product from the cells where they were housed. And then in purification, we go a step further by removing everything else that's contaminating our product, leaving us with a very pure, concentrated solution. In this program, we're going to look at a typical purification process used in the manufacture of GFP, green fluorescent protein. GFP is broadly used as a biological marker because it's very well tolerated by most cells and doesn't interfere with normal cellular function. We'll examine the technologies, equipment, and materials used, how to prepare for the process, and how the GFP purification process is managed, step by step. There are two main operations used within purification: chromatography and filtration. Before we can appreciate exactly what these process steps are accomplishing, we need to take a closer look at what our green fluorescent protein has been through so far. Back in recovery, our harvested cells from fermentation were homogenized. Our target protein was inside each cell, so to get at it, the cells had to be ruptured. Homogenization freed a flood of cellular components, including membrane debris, cytoplasm, DNA, and proteins, including our target protein, GFP, and they were all mixed into the buffering solution used to suspend the cells. Most of these solids were then removed through centrifugation, or by centrifuge, but the liquid that remained, the clarified lysate, was still rich in biological products, including dissolved chemicals, proteins, and other impurities. Amazingly, through purification, we can target a single protein within this biological soup. In our GFP purification process, we'll be using multiple types of column chromatography. The column is a cylinder filled with glass, ceramic, or polymeric beads, which are engineered to interact with or bind with molecules based on one or more physical properties. Chromatography relies on differences. Each molecule has a unique set of physical characteristics, such as size, charge, or extent of interaction with water. Chromatography uses these differences to separate the target protein from other proteins and chemicals. Sometimes size is used to differentiate. Some beads have small holes in them and can temporarily trap or at least slow down smaller molecules as they travel through the column of resin beads, while molecules too large to enter the pores move around the beads and exit the column first. This type of chromatography is called size exclusion. In the case of charge, opposites attract, so a negatively charged chromatography bead will attract and bind to positively charged components in the process stream. Likewise, a positively charged bead will bind negatively charged components in the process stream. This charge-based chromatography is called ion exchange chromatography. And then there's water. Molecules that readily interact with and dissolve in water are called hydrophilic, water-loving, while those that don't are called hydrophobic, water-hating. Proteins contain regions that are hydrophobic and regions that are hydrophilic. Because water tends to form a shield around the hydrophobic patches within the proteins, they are not exposed to interact with the resin beads. By adding salt to the protein solution, we remove the water shield, exposing these hydrophobic patches on the protein and resin so they can interact. This is how HIC, or hydrophobic interaction chromatography, works. In our process, which uses ion exchange and hydrophobic interaction chromatography, the chromatography equipment is housed on a skid to make it compact and mobile. The main part of the apparatus is a glass column filled with resin beads, but we also have pumps to move the clarified lysate through the process, a supply hose and port to feed the column, a pre-filter to remove any remaining particulates, usually solid cell debris that has not previously been removed, before the clarified lysate enters the column, an exit port for the processed solution, and auto switching valves for directing processed solution to either waste or collection. To help monitor the chromatography equipment and the solutions flowing through the unit during the process, a number of sensors are located along the product flow path. There is an electrical conductivity sensor at the column inlet, a pressure sensor just before the pre-filter to help identify a filter clog, a flow meter to measure the rate of solution movement through the column, and an air sensor to ensure that no air has entered the flow path. As a solution leaves the column, it passes a UV sensor that reads optical density, a second conductivity sensor, and a pH sensor that measures how acidic or basic the solution is. The conductivity sensors let us know when a new buffered solution has filled the column. When the conductivity reading on the exit of the column matches the reading from the sensor at the inlet of the column, then we know the new solution has completely displaced the old one. The ultraviolet UV sensor monitors the concentration of protein in the product by observing the optical density of the passing solution. This sensor works hand in hand with the valves on the exit of the column. Through the controller program, we can set a protein concentration threshold. When the optical density of the solution leaving the column is below the threshold, the valve directs the flow to waste. When the optical density of the solution leaving the column is at or above the threshold, this means that solution contains our purified product and the solution is directed to a collection vessel. TFF, tangential flow filtration, is at its heart a simple process step. We're going to pump a fluid through and across a special type of filter known as an ultrafiltration membrane. The size of the pores in the filter material determines what passes through and what's held back. As with almost any filtering process, we can choose what we want to keep. The solution that passes through the membrane is referred to as the permeate. Because the pores of the ultrafiltration membrane are small enough to keep the product from passing through, the permeate contains no product and is sent to waste. The portion of the feed stream that does not permeate the membrane is called the retentate. It contains the retained product and is the stream we are most interested in. What makes TFF different is a core technology that enables it to be faster, more efficient, more flexible, and even self-cleaning. In conventional or terminal filtration, a fluid is pumped directly into a filter. The particles within the stream that can't fit through the pores of the filter build up at the filter surface, eventually clogging it. In tangential flow filtration, the stream moves across the filter, that is, tangential to the filter, instead of directly at it. The cross-flow current actually picks material back out of the filter media or membrane and into the stream. This retained material, called retentate, is recirculated to the supply tank and will continue to loop through the filter for as long as the process runs. We'll be using TFF for two different tasks within the purification process: concentration and diafiltration. We are processing purified GFP from a chromatography step. The fluid from the chromatography step is purified green fluorescent protein dissolved in a buffering solution. In diafiltration, we add new buffer to the GFP retentate while displacing the old buffer, effectively exchanging buffer solutions. Note, the GFP is retained by the membrane. If we don't add a new buffer, then we're concentrating our solution. Concentration is simply the removal of water and buffer components from the feed solution that results in a more concentrated solution of green fluorescent protein. From operation to operation, or product to product, the purification process can look quite different. It could be as simple as a single chromatography step, one cycle of TFF to concentrate the product, and final filtration. Or it could involve several different types of chromatography, diafiltration between chromatography steps, and a final conventional filtration. Our green fluorescent protein process is pretty typical of the process for biopharmaceutical products. The clarified lysate will be pre-filtered, go through anion exchange chromatography, and the GFP collected and pooled. Next, ammonium sulfate will be added to make the solution high salt, followed by hydrophobic interaction chromatography, HIC. The GFP is then collected and pooled again. The solution then goes through a TFF ultrafiltration step, which includes concentration of the GFP followed by diafiltration to exchange buffer solutions and remove salt. And the process finishes up with final filtration into bulk bottles or bags. It's time to gather everything we'll need for the purification process and ensure that the area and equipment are ready to go. The chromatography skid and TFF system are checked for proper operation. Process hoses are attached and examined for leaks. We verify that we are using the correct column resin and that the resin is properly packed. The column is filled with a storage buffer, and the product path is checked for trapped air and purged if necessary. Our raw materials include the clarified lysate from the recovery process, various buffer solutions that are tailored to specific process steps, and ammonium sulfate that we add to one of the buffers to make it high salt. The purification process is managed through the use of a batch record. There is a separate batch record for each processing operation. These documents lead the operator through the process step by step, with each step requiring a sign-off and separate verification by a second operator. The batch record also includes spaces for documenting times, activities, operation steps, and instrument readings. Before the process can begin, the purification area must be cleaned, disinfected, and organized. Any unnecessary equipment or materials are removed. All equipment must be cleaned, sanitized, and set up as required by standard operating procedures. All required materials and documentation must be gathered and prepared before the process may begin. The purification process begins as the transfer tank of clarified lysate from the recovery process is connected to the inlet pump on the chromatography skid. The first chromatography step in our green fluorescent protein purification process is anion exchange. At this point in the process, the pH of the clarified lysate is about 8.0, which means that the protein is negatively charged. Because it is negatively charged, GFP will bind to the positively charged anion exchange resin. The pump draws the lysate from the vessel, past the first conductivity sensor and pressure sensor, and through the 0.45 micron pre-filter. The pre-filter removes any residual cell debris or other particulates that may have contaminated the solution. If the pre-filter begins to clog, the pressure sensor at the inlet side of the filter will register a rising pressure, and the controller will signal the need for a filter change. After pre-filtering and before the column, the lysate passes through a flow meter and an air sensor. Then, as the lysate passes over the resin beads, the negatively charged protein binds to the positively charged beads. The solution leaving the column passes a UV optical density sensor, a conductivity sensor, and a pH sensor. The optical density sensor's low readings confirm that the GFP is not in the solution, so the outlet valve sends the solution to waste. When all the lysate has entered the column, or when the capacity of the beads to bind the protein has been reached, it's time for elution. Elution is the release of, in this case, green fluorescent protein from the beads by using a new solution, in this case a buffer that includes NaCl, sodium chloride solution. As the new buffer is pumped through the beads, at some point the GFP no longer binds to the beads and is released into the buffer. The resulting product stream is usually referred to as the eluate. The UV optical density sensor, which measures protein concentration, indicates when product begins eluting from the column. At this point, outlet valves are switched to allow flow of the eluate, the product stream, to a collection vessel. When the UV sensor indicates that all of the GFP has come off of the chromatography resin, the outlet valves are switched to waste. When all of the eluate has been collected and pooled, the anion exchange chromatography step is finished, and it's time for HIC, hydrophobic interaction chromatography. Hydrophobic interaction chromatography is based on the principle that hydrophobic chemicals on the resin surface will bind to hydrophobic patches on the GFP protein. In order for this to occur, the resin and protein eluate have to be in a high salt environment to remove the water shielding. The salt we use is ammonium sulfate. To remove the attached GFP protein from the HIC column, we simply lower the salt concentration during elution, causing the water shielding to reform, and the GFP protein detaches from the resin into the elution stream. The protein-rich eluate is collected and pooled. The product is now ready for the last major step, TFF. At this point in the process, tangential flow filtration will be used to concentrate and diafilter the GFP product stream. The eluate is rich in green fluorescent protein, but it's still too dilute and too high in salt. As the solution moves through the TFF apparatus, it leaves the supply tank, is pulled through a pump, past a pressure sensor, and then across the filter membrane. Everything that passes through the membrane, including the buffer solution, is known as permeate and, for this process, is sent to waste. The GFP protein is larger than the pores of the membrane and therefore is retained. The retained material, called retentate, is recirculated to the supply tank. Recirculation of the feed continues until the desired concentration of GFP is achieved. Following concentration, and while the protein solution is recirculating, a new solution, a storage buffer, is added to the feed. In effect, the protein is being washed by the flow of a new buffer solution in and the old buffer solution out. As this diafiltration step proceeds, the buffer solution that is being added to the feed replaces the buffer solution that the GFP was originally in, effectively removing any remaining salt as well. When this process is complete, the GFP solution is routed through a 0.22 micron final filter and then collected in appropriate containers, usually bottles or bags. The purification process is complete. The green fluorescent protein concentrate can now move downstream to final fill finish to be freeze-dried and packaged.
We can see how packaging, how things were developed here, how cleaning things, how the packaging, how the premises was developed, from production, from processing and storage and everything. So yeah, so I will share these things later on, and we see us tomorrow. We continue tomorrow. I have my another lecture of drug regulatory affairs, so I have to stop it here. So thank you very much for being there. I hope you have learned a lot today within this short span of time, and I see you then next time. Tomorrow we will see us, yeah, sharp at 8 p.m. then. Thank you very much. Wish you a nice evening. Good night. Take care. Bye bye.